Hey everybody, here is the lesson to go over our transformations of root functions or radical functions. We have covered transformations twice before. We covered them for quadratics and for cubics in previous units. You'll notice that we do have a very similar, or I guess familiar, equation here. This is the general root equation when we're looking at transformations. It's almost identical to the one we've already used for cubics and quadratics, but instead of the square root, it was just parentheses and then either a 2 or parentheses and a 3 right here. So everything else has stayed the same. I did add on here to help us remember how to know which way to go with certain transformations. Just to narrow it down, you can either be vertical or horizontal. So if you're on the inside of parentheses, or for this equation, the inside of the radical, so in that radicand, that's going to be a horizontal change. And if you're on the outside of the radical, which would be a and k, that is a vertical change. I'm just going to fill that in right here. Horizontal change and vertical change. And then here at the top, I have the parent functions. We have y equals the square root of x over here, and then we have y equals the cubed root of x here. When you're looking down at the pictures down here at the bottom, the parent functions that are at the top are going to be the dotted ones to show you how it started off. And then the solid ones are going to be what the change looks like. You can see that here as well. Dotted ones are the original. Those are the parent functions. And then the solid ones are after the transformation. Same for on this page. What we did during class was actually take a period of time and had everyone try to figure out what these spaces were here based on what we'd already covered to see if we could recall any of that information. I did provide, though, a word bank right here. So we're going to use these words to help us figure out what kind of transformations we have here and fill them in. You will use each word or phrase, really, once, and you'll use them all. And they're going to fill in the 4 blanks over here and then the 8 blanks that are on this first page. So go ahead and pause. I'm going to come back up here. There we go. Go ahead and pause on this word bank, fill in the lines that you can, and then come back when you're ready. Welcome back. Let's go ahead and go over what blanks you got filled in. I'm going to start with what personally I think are the easiest ones, which is going to be the ones on the second page here. Normally we can easily tell when we go up and down and left and right. I'm going to zoom into here first. This says the value for k can help you figure out the vertical translation. Remember, vertical means up and down, this direction. And it says here when k increases and when k decreases. What we're going to do that I didn't already tell you to do is write down what our center points are, or for a square root technically it's called a starting point and an ending point, but I'm just going to use the word center so we don't get confused. Here the center point is 0, 0 for our parent function, and that's going to be true for all of our parent functions here. We can go through, even if you want to fill them in on every single graph, always going to start at 0, 0. And then looking back over here at k on the left graph, which is the one that has a +2 for k, you can see our new center is 0, 2. So you can see how we gained 2, we went from 0 to 2. And our graph did move up 2 spots. Remember, your k is vertical because it's on the outside of that root. That's why it's back there. And then the other direction, if we want to go down, this one here, our center is now at 0, -2. You can see we scooched down 2. And you can see that right here with our k being a -2. I have also provided on each of the examples how to do it algebraically in case you don't want to have to use a calculator. I have included what to do and then an example of how that changes your dots as well, or your coordinate points. Looking at our other movement, which is just going left and right instead of up and down, it says the value of h can help you figure out the horizontal translation of the graph. Remember, horizontal goes this way. It says appears -h and then appears +h. The reason we're phrasing it like that is because if you're on the inside of the radical, like this, or for our cubes and quads, it was when it was like on the inside of the parentheses, this part, right? If you're on the inside, it's always going to be the opposite of what it looks like. So if it appears to be a -2 for H or a +2 for H, it's going to go the opposite direction with which you think it will. When H appears negative, it's going to go this way over here to 2, 0. See, we actually gained 2, but in the equation it says -2. That's because that minus sign belongs to the formula. So it's always just going to go the opposite of what you think it will if it's on the inside. Looking over here at our +2, so here H is +2, well, air quotes +2, but on the graph you can see it's -2, 0, because it's going to be the opposite of what it looks like, so that made it go to the left. Perfect. Now let's look at the other page. I have filled in these as well. I'm just going to go with A first, then we'll move on to B. Looking at A, it says the value of A can help you figure out the vertical reflection. So if I'm reflecting vertically, that means I am going this way. And you can see here, I was here, and then I flipped this way. If you want to add the arrow, if that would help you can do that right here. There we go. And I'm just going to mark A on these. A for this one changes to -1. Also changes to -1. You can see I went from +1A to -1A, and that made it flip down, which is why we said right end down. The reason we're phrasing it like this instead of just saying vertical reflection, which we'll say on the other page, is because in the future we'll focus a lot on end behavior, and that's going to be looking at that right end for A. And then, like before, I have included how to do it algebraically for all these as well. Looking over at the other part of A, it says the value for A can help you figure out the vertical dilation of the graph as well. Here is an example. Let's go ahead and mark that. So obviously our dotted line, remember we said that was the parent function. That means A is equal to 1. And then for the other ones, here I have A equal to 2. And then this one is A is 1/2. So when A goes from 1 to 2, so as it gets larger, you can see your graph before was this tall, and now it's this tall. It got taller. And that would be called a vertical stretch because you would be pulling on the graph this way, and that would stretch it out to make it taller. Looking at decreasing, I went from 1 to 1/2, so it did get smaller. It was this tall. Let's see. So it was this tall before, and now it's only this tall. Right? It got shorter, or I like the word squattier, personally. I think it makes sense. That's because we are compressing top to bottom like that, which makes it shrink down. So that'd be a vertical compress, and visibly it would be shorter. Still, these two boxes here are a vertical change because they're on the outside. And now I'd be looking down here for our last horizontal change because that's on the inside of the radical. It says here the value of B can help you figure out the horizontal reflection of the graph. When you're reflecting horizontally, you're reflecting this way. So as you can see, we went this direction. This one went this direction. Obviously, this one circled around. And for these, we just mentioned the left end. If I look originally, the left end is down. And then as it flips over this direction, the left end is now up. I'm going to go ahead and label that here as B, -1, and here's also B of -1. And then lastly, we have the value of B can help you figure out the horizontal dilation. This is definitely the hardest one, in my opinion, for both people to be able to figure out, because the inside situation of it making everything opposite is kind of confusing. So here we have a graph. Here is a B value of 1. And then for the solid graph, it's a B value of 2. So for this one, our B value goes from 1 to 2. It gets larger, or it increases. And you can see our graph was this tall, and now it's this tall. So a little bit taller. It did get taller, but horizontally, the way it would get taller is if you push in from here and push in from there, that would make it kind of scrunch up and get taller. So it'd actually be a horizontal compress, even though visibly it's still taller. Sorry, there we go. I said 1 on accident. And then our last graph here We have a b value of 1 for the dotted, for the parent function, and then our new function has a b value of 1/2. So b did get smaller. And if you look at our graph, it was this tall, and now it's this tall. So it did get shorter horizontally. If I were to pull this way, that's what would make it shorten up. So it'd be a horizontal stretch, even though visibly it did get shorter. And there we go. Perfect. So I'm gonna go back over here and we're gonna try to do a couple of these. We can do 1 and 2 together, and then you can try 3 and 4. I am gonna use my Desmos calculator to help me out with this because that's the one you're gonna be using at home. So I think that would be most helpful. And it says identify each transformation given a sketch of the graph, and then the parent function is already given. So the dotted line again is the parent function that has a center of 0, 0. We want to find our new center. Remember, centers are h comma k, so I'm just going to label where h and k are. K is right here. I don't have an h. There is no h, a number on the inside. So that would be 0. So if you don't see an h or a k, it is 0. So my new center is going to be 0, -4. Be right there. And then what I'm going to do is graph it on my calculator. I'm going to go ahead and slide over here, grab Desmos. There you go. And then I'm just going to graph this in the calculator. I'm going to push the square root button. -x is on the inside, and then -4 is on the outside. And once you've done, let's go find it. Here it is. Now we have a couple options. You can just trace along the line to try to find whole numbers, right? I always want to be able to graph a whole number. Let's see if I can find any. These are kind of a pain, but I will try. I think there's one right here. Oh, maybe not. There we go. -9, -1. I actually don't have that on here. It'll be like right there. There's got to be one in between, though. Let's keep looking. I think there's one right there. Let's see what that is. Boop. There we go. There we go. -4, -2. All right, there. Now I'm just going to connect the dots. And that's our graph. And we'll just list what had happened. So we saw it move. As you can see, comparing it to its parent function, right? The center hasn't moved left or right. It's just moved down and went down 4 spots right here at K. So I'm going to say down 4. And then you can see it's facing the other direction, right? It started off facing this way, and now it's facing this way. So it flipped along this, which would be horizontally. You can see that right here. So I'm going to say a horizontal reflect. And then I don't know if it got skinnier or sorry, shorter or taller. I would look right here. This number isn't different. It's still just 1. And then out here, it's also just a 1. So it looks like we just had those 2 changes right there. And that's how you do it. Let's try the next one here. This one is a little different in the sense the center's kind of off. So when you have a value for b that does throw off your center, right? We would think the center, let's see what we think the center would be, h and k. So my presumption is that the center would be at 2, 0 because I have 2 here and there is no k there. However, because I have this 3 here, that does skew the movement right here. So you're going to have to divide by that 3. So the center will actually be at 2/3, 0 because we had to divide by that b. I don't want you to worry about memorizing that. It's a pain. Just go off what you can see on the graph. So let's go ahead and graph it. Good. So here we go. Now I want to graph this one as a cubed root this time. So I'm going to go to functions. So I'm going to scroll down here all the way to the bottom. And you see we have under the word floor, we have this root here. It has an in there for index. And we can put whatever root we need. We need a 3. And then inside I have 3x minus 2. There we go. Kapow. Okay, let's see what we got. There's our center right there at 0.66 repeating, 0. So that would be at, we said 2/3. Put that there anyways, even though it's not a whole number. And then we also have our y-intercept there. Also not a whole number, but I might as well draw it on there. Or like right there. And we want a whole number. Let's see if we can find a whole number. Looks like there might be one right there. Or at least close to one. Oh, there we go. -2. There we go. -2, -2. Right there. We'll look for any more whole numbers that we might see. It looks like this one isn't exactly a whole number, but it's very close at -8, -3. So we can probably estimate that one. Look at that. And let's see if we can find any on this side. Let's see. Ooh, that might be one right there. Let's see. Ooh, really close, if not. Oh, 2.5. Boo. Okay, hold on. Let's keep looking. We got 10, 3 is pretty close. Man, not much for anything over here, huh? There we go. 1, 1. 6. 6. I'm gonna do 6, 2.5. Right there. Okay, that should be enough. And then we'll just connect our dots. That was kind of hard to find. And then I'm going to list out what happened. Here we had a movement, right? Remember our center, well, it went this way, but technically it wasn't a move of 2, right? We did move to the right. And we technically went to the right 2/3 because we had to divide by that 3, the change there. And then that 3 is on the inside, it's change in B. So let's look at what we got over here. Change in B. And when B gets bigger, you can see that right here, it is a horizontal compress. So H, compress, because it did get taller. You can see it's taller than that dotted line we had before. And that's how you do it. So go ahead and pause, go try these two, and then come back when you're ready. Welcome back. Here is 3 and 4. Look at 3 first. I marked H and K first, so my center was at -2, 0. I didn't have any change in B, so we're good there. Didn't have to worry about moving it. Here's what all happened. You can see it flipped over. So that was a vertical reflect. I know it was vertical because the negative was on the outside, not the inside. It was a vertical stretch. I know it was vertical because the number is on the outside, not the inside. I know it was a stretch because it got taller. You can see my dotted line is this tall, and my actual line's way taller than that. And then it moved left 2 because of this +2. Remember, I got all my dots from over here on my graph. The green one here, I just traced until I found the dots, like with whole numbers and stuff. And then number 4 would be this one, this purple dot here, or purple line, sorry. This one was a lot harder to draw because there wasn't a whole lot. That was a whole number. So I found the center. It was at -1, 1. Okay, there's my, I forgot to mark my H and K. There we go. So that means I went left 1 and up 1. There's my new center right there. And then I had a vertical compress. I know it was vertical because the number's on the outside. I know it was a compress because it's very short compared to how tall the dotted one was. And then I found my whole numbers here on my graph by tracing. And there we go. Perfect. I hope this helped. Just a reminder, you can go find your old notes on transformations for quadratics and cubics as well if you need some more help. Have a great day. Bye.